Okay, we want to find the exact values for all the solutions in complex and polar form. So let's hang hoof and ride the wave. All right, so can I get all the solutions and can I get them exact and not decimal approximations? Well, the 6th root is 729. If it comes out nicely, I could be in luck. What is the 6th root of 729? Oh, it's just 3, right? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. And then 243 times 3 is 729. If you want to check with the calculator, go ahead and check with the calculator. But all my solutions will be 6 units away from the origin. Right, so it's a circle of radius 3. And because there are 6 solutions, the solutions are going to be 60 degrees apart. So here are the 6 solutions, and those are exact locations. Right? 3, 0 degrees, 3, 60 degrees, etc. Now, if I want to change it to complex form, I know for the real number component, it's going to be 3 times the cosine of the angle. If I want the imaginary component, I'll need to do 3 times the sine of the angle, remembering to put the imaginary friend I on there. Now, we did this example previously, and those were the answers we got, because those were rounded off, right? That 2.6 is not exact, it's rounded off. So what can I do if I want to make? That's right, our friend has come back, the unit circle. For 60 degrees, if I want exact answers, notice at 60 degrees, cosine is exactly 1/2, and sine is exactly root 3 over 2. So if I want to take each of those points that are exact in polar coordinates and rewrite them exactly in complex form, I can do that. Of course, at 0 degrees, cosine is 1, so 3 times 1 is 3. Sine is 0, well, 3 times 0 is 0. 60 degrees, well, 3 times 1/2 gets me 3 over 2. 3i times root 3 over 2. Well, there it is, 3i root 3 over 2. 120 degrees. Ah, I've got a negative 1/2. So 3 times negative 1/2 is negative 3/2. 3i times root 3 over 2. There it is, 3i root 3 over 2. 180 degrees. I'll have to do 3 times negative 1, and then 3i times 0. Well, 3 times negative 1 is negative 3. 3i times 0 is 0. Oh, hey, it's just negative 3. 240 degrees. And again, you'll notice the pattern that we're reusing numbers. Right? We keep reusing that 3/2, although sometimes it's positive 3/2, sometimes it's negative 3/2. And we keep reusing the 3i root 3 over 2, although sometimes it's positive, sometimes it's negative. But as we work our way around the unit circle, we just keep reusing those same values. Because if we're going to go every 60 degrees, we're always going to be looking in a 30, 60, 90 triangle. And the ratio of those sides never changes, right? 30, 60, 90 triangle. So hopefully we just refreshed our brain from some of the trig that we did, quite a few months ago. But those are the 6 answers exactly in polar form and exactly in complex form, right? Instead of a decimal approximation, I can get exact answers. Now, this is only going to work if we are dealing with 30-degree angles or 60-degree angles or 45-degree angles or 90-degree angles, right? If there's some weird number like 72 degrees, out of luck, right? It'd be, well, we could get an exact value, but it's very, very messy. We'd have to start using double angle values, half angle values, sum and difference formulas. But if it comes off a 30, 60, 90 triangle, or if it comes off of a 45, 45, 90 triangle, we can get exact answers. Right? So that's what it looked like when we were just going for the approximations. Right? 3 over 2, of course, was exactly 1.5. But if I want to take that 3, multiply by root 3, and divide by 2, sure enough, that's where that 2.6 was coming from. Right? So that 2.6 is a good approximation, but the 3 root 3 over 2 is an exact value. Okay, so let's do one more example. X to the 8th power equals 256. Now, of course, it's really quick in polar coordinates to find all solutions. I know the 8th root of 256 is just 2. Use a calculator if you need to. I know there's going to be 8 solutions. I know each time there'll be 2 units from the origin. And because there are 8 solutions, they'll be separated by 45 degrees. So those are my 8 solutions to that equation. Right? It's always a distance of 2. And I just keep adding 45 degrees as I run around that circle. Now, if I want it written in complex form, well, 1 comma 0. So I got to do 1 times 2. And I got to do 0 times 2i. 45 degrees. Let's do 2 times root 2 over 2. And let's do 2i times root 2 over 2. There are the answers. 90 degrees. 0 times 2 is 0. And then 2i times 1 is going to give me 2i. 135 degrees. I bet we reuse some numbers here. Right? 2 times negative root 2 over 2 becomes a negative root 2. 2i times root 2 over 2 becomes I root 2. Of course, 180 degrees, the answer better just be negative 2. 225 degrees, again, we're going to reuse some of these values, but because of the quadrant we're looking in, both values are negative. So I get negative root 2 minus I root 2. 270 degrees, bottom of the unit circle, right? Traditionally, the x coordinate would be 0. Of course, that's now the real number coordinate. Traditionally, the y value would be negative 1. Of course, now that's the imaginary component. So negative 1 times 2i just gets us negative 2i. Finally, as we hit 315 degrees, we'll be reusing some of those values. Of course, quadrant number 4, the x-coordinate is traditionally positive. Of course, instead of an x-coordinate, we talk about our real number component. The y-coordinate has always been negative in that quadrant. Of course, instead of the y-coordinate, we're talking about the imaginary component. But those are the 8 exact answers in polar form and the 8 exact answers in complex form. Right? If you took any one of those answers and raised it to the 8th power, you would get 256. All right, so let's ride that wave and take a look at the worksheet. Go, cow, go. Well, that's one slow surfing cow. Must have been crashing in the waves.